My dear students, this is Ansuman Chakraborty, Administrator of Archana Institute of Technical Education and Research. As it has already been provided in the class routine, in which we are scheduled to take off with the online classes, as because our normal, regular, routine classwork or the classroom teaching has been hindered due to this corona pandemic situation. I have left it no other option but to train you up or provide you up with teaching in form of these online digital classes using the social media platforms and through the YouTube channel of Archana Institute of Technical Education and Research named as ITER PCT. So without wasting of much time, in the last two lectures, we have discussed about the fundamental concepts of the paper, that is fundamentals of geology and geomorphology, and here we will start from today discussion into the interior of the earth. So in this particular lecture we will basically know about the different pros and cons of the earth's surface, as well as what are the different layers of the earth. That is the first and foremost object of analysis and study over today, as well as the different characteristics of the different layers within the surface of the earth. The object of analysis and study over today, as well as the different characteristics of the different layers within the surface of the earth. So in the very first, let me just be specific and specify you. The earth will consist of four broad layers, or the crust of the earth can be divided into four broad layers. They are the earth's crust, mantle, So as we have been discussing, basically the layers of the earth surface can basically be classified into four broad layers, or it can be divided into four broad layers based upon its constitution and the depth of the respective layers. Now the four layers are: number one, the earth's crust. After that, if we just go downward, the next layer that we will come across will be the mantle. It is to be followed by the inner core, and finally the outer core. So here let's first discuss about the crust of the earth. What does the earth's crust mean, or what do you mean by the term earth's crust? It is basically the hardest and the most thinnest portion of the earth, and to be much more specific, it is the outermost layer and extends only a few miles or kilometers, say up to 5 kilometers below the oceans, and averaging around 20 miles, that is 30 kilometers under the continents. It is basically available in a solid form, and the basic composition of these layers includes the iron, oxygen, silicon, magnesium, sulfur, nickel, calcium and aluminium respectively. Now the crust of the earth is basically be subdivided into two broad types. One is the oceanic crust, while the other one is the continental crust. Now the oceanic crust are basically made up of the basalt, that is an igneous rock, and it is basically found under the ocean, having a relatively thin or being a relatively thin layer of 5 to 7 kilometers, and this particular layer contains more iron than the continental crust, and hence it is comparatively much more dense in comparison to that of its counterpart. Now what is continental crust? The continental crusts are basically made up of granite, and they are being found under the continents, and they are relatively thick and stretches up to something 100 kilometers. Now in the very next, this particular crust of the earth can be classified or can be described as two broad layers. One is the lithosphere, while the other is that of the asthenosphere. Now what is lithosphere? It is the uppermost part of the crust, which is basically broken into larger plates, and the uppermost part of the mantle is also considered to be as a part of our lithosphere itself. Now in this context, I would like to mention that the crust of the earth, that what I am mentioning about the oceanic crust and the continental crust like this, the oceanic crust are basically made up of silicon and magnesium, that is SiMa, while the continental crust are basically made up of silicon and aluminum. So the abbreviation goes as Sial. Now what does the term asthenosphere means? Asthenosphere basically means the upper part of the mantle, and it lies just below the lithosphere, extending around 130 to 160 kilometers. Now it is the cooler part of the mantle that the lithosphere plates slide on the top of it. That is, all the plates which we come to know about, the continental plates or the oceanic plates, as it are reflected in the plate tectonic theories and other things, basically rests upon this layer of the asthenosphere. Now what is a lithosphere? As I told you, the lithosphere is basically made up of mostly the crust and several constantly moving plates of solid rock that hold the continents and the oceans. Now the lithosphere is basically made up of the solid rock. Now what are the basic constituents of the lithosphere? It is oxygen, silicon, aluminium, iron, calcium and sodium. These are the basic constituents of the lithospheric plate or the lithosphere surface. Now what is asthenosphere? It is basically the plate of the lithosphere on which the plates, that is the oceanic plates or the continental plates used to float upon. To give its characteristics, this is basically a hot, malleable, semi-liquid zone which is basically being present in the upper part of the mantle. This asthenosphere is basically constituted of the solid rock, just we see as in the case of the lithosphere itself. And the basic constituents of the asthenosphere includes oxygen, silicon, aluminium, iron, calcium and sodium. Now what is the basic difference? Sometimes a question comes up in the examination also, that discuss in brief the basic differences between the lithosphere and that of the asthenosphere. So I will just specify you some points, that what these particular differences are between these respective two layers. So first of all, in terms of this lithosphere, rocks in the lithosphere are basically rigid, meaning that they can bend but they cannot flow, while rocks in the asthenosphere are basically plastic, that is viscous, and they can flow in response to the deformation. This is point number one. Now the point number two, in asthenosphere even the rocks can flow, but still the rocks that are found in the asthenosphere are basically solid, though the rocks that are found over there are not liquid. And in case of the lithosphere, it is completely solid. Now lithosphere is made up of the crust plus very upper part of the mantle, whereas asthenosphere is the only upper mantle material. So both the lithosphere and the asthenosphere are basically made up of solid rocks. So these are the three integrate points. First of all, rocks in the lithosphere are basically solid, while rocks in the asthenosphere is basically viscous or semi-liquid. Second, the rocks cannot flow in case of the lithosphere, but the rocks can flow subject to the frequency of deformation in case of the asthenosphere. And third, a lithosphere consists of the earth's crust, that is the solid portion only, as well as the asthenosphere is basically consists of the upper part of the mantle. These are the three basic points. Now this is a diagram. This particular diagram shows that this is the ocean, this is the lithosphere. Now the lithosphere is basically divided into the upper part as the continental crust. As I told you, the continental crust rests upon the oceanic crust, and it also contains the upper part of the mantle. And this particular schema is basically being basically can be explained as a cross section of the earth. Now this particular cross section shows the innermost layer of the earth comes as the inner core. Just on it lies the outer core, and the outer core is being preceded by the mantle or the asthenosphere, and the mantle is basically being preceded by the lithosphere. And over the lithosphere, that is over the surface of the earth, the different layers of the atmosphere crops up or comes up in. Just to cite an example like troposphere, tropopause, stratosphere, stratopause, like this, it goes on. Now, in this particular diagram, as you can see, the innermost part of the earth is basically known as the inner core, and it is basically composed of the very solid material with nickel and this ferrum, that is the nickel and iron. While this outer core, it is basically in a viscous condition or in a molten state. It is being preceded by this particular mantle, as I have discussed in the previous slides, and finally over this particular mantle comes up the Earth's crust, that is the lithosphere, which can be classified into oceanic crust. Now, as I have been explaining, in my previous lectures, or as I have explained just in my previous slide, it is a much more vivid view. This particular diagram is a much more vivid view of the crust of the earth, or the different layers of the earth's crust, which in which you can see that the continental crust are basically lying above the oceanic crust, which are basically comparatively thicker in comparison to that of the continental crust. It is being followed by the uppermost part of the mantle. Then comes the asthenosphere or the inner mantle. Then comes the outer core, and after that comes the inner core. Now, what is the earth mantle? The earth mantle is basically located directly above the outer core, and it starts below the crust of the earth. It is the largest layer and comprises 80% of the earth's volume and 68% of the total mass of the earth. Now, some other characteristics includes it is basically composed of more iron in comparison to that of the earth's crust. Density, pressure and temperature all increases as we go deep towards the mantle, and temperature here ranges from 870 degrees Celsius to 2200 degrees Celsius. So this is about basically the mantle of the earth. Now, in this particular diagram, as you can see, this is the mantle or asthenosphere. Now, one thing that needs to be specified, that this particular crust and the mantle and that of the core are basically being divided or basically being separated by some kind of discontinuity lines. The two discontinuity lines that used to separate this lithosphere with that of the asthenosphere and asthenosphere with the mantle are convex discontinuity and monovisic discontinuity. Now, what are these particular layers of the mantle? First of all, it is the lithosphere, that is crust plus the upper solid part of the mantle. It basically forms the plates. And secondly, the asthenosphere. Just it rests under the lithosphere. These are slowly moving layer on which the lithospheric plates used to slide. Now, this is a cross-sectional diagram as I have explained in my previous slides. Now, what is the core of the earth? The earth's core is basically composed of the inner and the outer core, and both of them are basically comprised of iron and nickel. Now, what is the outer core? What are the basic characteristics of the outer core? The outer core is basically in its liquid state and it surrounds the inner core. The temperature of the outer core ranges to somewhat around 2200 degrees Celsius to around 5000 degrees Celsius just near the inner core. And it is basically available in a molten state comprised of iron and nickel. So in terms of science or in terms of chemistry, we can term it as Nife, that is nickel and ferro. Now this is a cross-sectional diagram. Just you can see that below the mantle lies our core, and this area marked in yellow is the outer core, while the area marked in white is the inner core. Now the outer core is something around 1400 miles thick, and it is comprised of liquid iron and nickel, while the inner core is basically lying just below this outer core. Now inner core of the earth. The inner core of the earth is basically in its solid form. Now you may ask that why the outer core is in molten state and why the inner core is in solid state. This is because the inner core of the earth is basically comprised or made up of the solid iron and nickel because of the incredible pressure that lies within the crust of the earth, or that lies below the earth's crust. The solid core is basically the source of the earth's magnetic field, and here the temperature is something around 5000 degrees Celsius. So if we just drop even if a drop of water, a droplet of water is finished in a fraction of a second. It is so much hot. Now as I am telling you, the inner core of the earth is also regarded to be as a magnetosphere, or it comprises of a magnetic field. It is basically because the inner core and the outer cores do not turn at the same speed as the rest part of the earth used to do. And this particular sphere or zone causes a generator effect which produces a magnetic field. This particular magnetic field or magnetosphere protects us from some of the sun's most harmful radiation. This is the particular diagram. Just for your understanding, I have put this is basically the inner core and this is the outer core, and you just see some radiation from the sun are coming or penetrating below the surface, and they are gradually being absorbed by these respective layers in form of the magnetosphere, and therefore helping us or helping the human civilization to get rid of this particular harmful radiations are concerned. Now Aurora Borealis, I think all of you have heard, and Aurora Australis, all of you have also heard. Basically some kind of special light that is available in the Scandinavian countries or in the the subpolar regions or something, especially during the winter. So this Aurora Borealis as well as Aurora Australis are also being created as a result of this magnetic effects or as a result of this magnetosphere. Now after that there are two questions which has also came into my mind while I was preparing up these slides. What does the inside of the earth looks like, and how does the scientist know that there is a solid inner core? So let's try to find the answer of both these questions. Basically the scientists as well as the geographers, for both of us it is not possible to see the interior of the earth or to drill to the core. But what we basically use is that we basically use seismic waves to determine the composition of these layers. Now what are these seismic waves? Seismic waves are basically the vibrations that are produced when an earthquake happens. Now seismic waves travel at different speed depending upon the composition and density of the material. Measuring these particular waves helps us to identify the different layers of the earth as well as its different material compositions or mineral compositions. So that is the basic way to have some kind of idea about the internal structure of the earth as well as its compositions. Now this is just a schematic diagram I have given. You just see the P waves and S waves. These P waves and S waves are basically being radiated or generated from these epicenter points, and they are trying to reach the core, that is the solid inner core or the liquid outer core, and then they are coming towards the Earth's crust where they are basically being recorded, and with being no direct S waves over here. And this particular records or this particular frequencies helps to provide us with an idea regarding the composition or the depth of the different layers of the Earth's crust. And finally, I would like to let you know with some interesting fact about the Earth. I think probably most of you doesn't have a proper insight upon. First of all, Earth is not a perfect sphere. This is number one. Secondly, Earth spins just over 1,000 mile per hour, and it is revolving around the Sun just at over 67,000 mile per hour. And this is important also because in the next classes when we will be studying about these different effects and different process of erosions and other things are concerned, so this particular speeds and other things needs our insight. After that, in the moon surface also, or on the lunar surface also, quakes used to occur, and such kind of quakes are known as moonquakes, just like that of our earthquakes. Now another important fact is that Antarctica contains about 70% of the Earth's fresh water, while 90% of the ice. Next, since the early 19th century, Earth's magnetic North Pole has been creeping northward by more than 600 miles according to the NASA scientists. Now this rate of movement has increased with the pole migrating northward, currently at about 40 miles, that is 64 kilometers each year. So you can easily imagine what may be the particular outcome finally if it totally creeps in. And finally, Earth may once had two moons, Tennessee second moon, that is spanning around 700 miles or 1200 kilometers wide, may have orbited Earth before it catastrophically slammed into our present day moon. That Earth has got two moons. The one moon is the normal moon which we can see, while the other moon is the Tennessee second moon, and it has got a total, the diameter of around 705 miles or something, and which has got slammed of the earth or something. I hope if you still have some kind of queries, then please feel free to contact me at cso.pctgis@gmail.com, or you can call up in my mobile number to provide you with the detailed clarifications. And one thing I would like to mention that the next class on fundamentals of geology and geomorphology will be on 24/5/2020 from 4 p.m. onwards. And on that particular day, we will basically study about the different types of rocks and their identification in the field. Till then, goodbye and have a sound stay at home. Please be safe. Don't roam outside or move outside, and feel free. That's all. Thank you so much. Jai Hind. Vande Mataram.